All right. I just got a bunch of practice problems for you today for stuff that'll be on the exam.
Okay.
Oh, applause. Okay. So yeah, you want to know all the reactions. As I said, this course is cumulative. Everything comes back. There will be multi-step syntheses on the exam where every reaction's fair game. You might need to pull something out from a couple weeks ago. But you will still have that list of reagents like you did on the last exam. So you just got to know what they do. The other major component is distinguishing those substitution and elimination reactions. And yeah, in the multi-step synthesis. So first up, I just wanted to practice a couple of these bicyclic Diels-Alder. So that's where we're starting with a cyclic diene. I'm still just putting a little heat for all these reactions, because again, we usually end up heating Diels-Alders a little bit. So these will all lead to bicyclic Diels-Alder products, and I challenge you to draw the side view, the fun version.
Are you supposed to draw the side view?
I think so,
What if we draw the regular view?
as long as it's correct.
Can you draw the side view?
I'm going to draw the side view. I think the side view gives a more accurate representation of how it's shaped.
Probably just look it up.
Oh, really?
I'll see so.
Oh, and then these ones are down. I think.
And then it's the alternating, like, Victoria was like above or something.
You turn it off.
And those are in the same direction that these are.
Oh, wait.
That basically
Is that, oh, there's two. This one, no, sorry. It's not like this, or this is moved back here. This is the other. Oh, oh, okay. Oh, so that was the here. And this moves back to here.
Yes.
But, so this doesn't. Oh, awesome.
Oh, it's a venue.
I'm sorry? What did you say? You don't know how to draw triangles?
told you to be more than
This should be off. So one needs to be. Oh, great. This is chair. No. Plus the end.
I keep drawing this one. Yeah, well, what?
Mine was 82. Which I don't understand. It's because like listen to some Frankie Valli in the Four Seasons. It's like literally like, it's not even what I listen to the most. It was just like it just like that I did that one song.
These are both down.
And then I think I have to say this again, but there's no end in the first one because it's not.
No. Also, this is gonna be put there actually. How do you put that? Because the red. Either above or below. Oh, yeah. So why would it look like it?
Yeah, you're supposed to.
You said I challenge you. I didn't say we practice.
That's my guess.
Oh, 6, 7.
Never.
You started it.
I might fail this last one.
Wait, but doesn't one have hella products?
Huh?
Doesn't one have hella products? Just these?
I don't.
I don't.
Well, we don't have to show it.
Alright, boom.
Also, this is not right.
Alright. Because they're both down?
No, because you need to. There's like some like weird funky thing going on in the middle of the ring. You don't have enough there. Because like this part of the ring like flips up. So and then like this attaches. So like this is not the same ring. You know what I mean? Like there's like something going on there. Something like that.
It's The guy in like a sleeper.
With some antennas.
Yeah.
It's like an ant. Remember when we had to draw the alien from Dawn?
Oh yeah.
But it was in the Davis classroom and all. It's in the first.
Cause like,
In the back. You go to the back of the library. Oh, I know. But there's like statues.
It's like you walk.
Back to, like, if you go to the IT.
what? No, we're just saying like, from our FYS, is
Yeah,
there anyone that
like,
you
yes,
still
there's
friends
a.
with?
Yeah, that's what Henry. I was gonna go.
Don't have to be perfect. But I usually start these by just drawing the 6-membered ring that the Diels-Alder is going to form. This was a 5-membered ring. So my bridge is going to be just 1 carbon.
Artistry.
Can't forget the artistry.
And he erased it.
There's the pi bond that formed during Diels-Alder. Where my dienophile was, we retain 1 pi bond because that was a triple bond. We only used 1 of those 2 pi bonds to make the Diels-Alder. And because it's a pi bond, that's trigonoplanar right there. So I'm just kind of approximating trigonoplanar geometry. And same deal over there with those methyl groups. So let me number real quick. So this is kind of how I tell how many carbons go in my bridge. So that was carbon 1, that was carbon 5, 4, 3. Carbon 2 goes up top, because it was the one not involved in the pi system. That'd be 6 and 7. We all see where that ring comes from? Not the prettiest. I'm gonna go straight up there. I'm gonna keep this line parallel to the side lines. And then just straight down. My new pi bond is there. I have no pi bond here because that was just an alkene. I need my methyl groups from the diene. And these were trans, so they've got to be opposite each other. We don't use wedge or hashed wedge on the perspective drawing. I go straight down if it's on a hash. And I kind of just pitch upward if it's on a wedge.
For the methyl groups like coming off of the ring, like how do we know that's the way we should draw them?
So the bridge is effectively up.
Mm-hmm.
So these I just want to kind of pitch downward.
Okay, I see.
If you build the 3D model, I mean, this is tetrahedral right here. So these do kind of pitch down like that.
Yeah.
You have to say plus EN or
for this one, yeah, I guess you would get the enantiomer there too. There's my new pi bond from the Diels-Alder. It has that methoxy group coming off of it. These are both asymmetric, so now I gotta decide what the regioselectivity is. You could draw out the resonance structures, but you could also just remember that when this is on like carbon 2 of the diene, and this is an electron withdrawing group, that you're gonna get the para type relationship. So it'll be on this carbon. And it's gonna go straight down to signify the endo product.
Can you number?
Sure. So I had to flip it around to match with the resonance.
So, what is your advice with counting? Because you count, like, what way should we count? So we're consistent for.
So you can number however you want. I'm kind of arbitrarily picking where I start with one. But I'm numbering here mainly just to keep track of where everything's going.
Yeah, but over here.
Like
you
if
could-
we number it
but, like-
differently and it's on different parts of it, but it's how we numbered it, is that wrong?
Like, how are you consistent with the counting over here?
I guess I think of it as starting with the 6 atoms that make the new 6-membered ring. So I'm mainly concerned with where these 6 end up. And I'm matching up 6 with 5 here because that's what the regioselectivity demands. And then the other numbers just end up with whatever they were connected to. It's like 1 isn't involved in the reaction, but I know that it's connected to 2 and 5. So after I've drawn this 6-membered ring, I know, oh, I need another carbon that connects 2 and 5. Yeah.
So whenever we have like example like this one where it's not the same on each side of the double or triple bond, should we do the like resonance structure to see how it bonds?
Yeah, I mean, that's the long way. That'll work. And you could also just remember, okay, if it's here, they'll be kind of the para opposite each other. And if this donating group was here, they would be ortho. So like right next to each other. You can just remember that, but if you can't, you can always rationalize it with the resonance. It just takes longer. It's a little... Any other questions? Those feel okay?
I said across the end.
No, not here. Here the enantiomer would be the exo, and we're going to prefer the endo product. Okay, let's try a different type of problem. So this is more akin to a real-world problem for an organic chemist, where you want to make something, you've got stuff you can start with, you got to figure out how to get there. So again, I just want to push you to use retrosynthesis as your strategy here. There are far fewer things you have to consider if you go backwards. So from the reactions we've learned, things that put a hydroxyl on the end of a chain, there's not that many of those. I'd say probably hydroboration does that. We could have hydroborated this alkene, anti-Markov addition. Sticks that OH on the end. Adds an H right there. And you can also
those three?
That's the hydroboration reaction. And I'm also thinking, just because of the reactions we know, it's mostly alkene reactions, right? So we're probably going to have alkenes as an intermediate most of the time here. So I'm thinking about right away looking at this, what alkene could this have come from? If that's on the end, well, probably that. If I'm headed here from this alkene, well, we have that methyl group out here already, or at least a carbon out there that can become a methyl. But we have to get rid of this Br. So what do we know that gets rid of bromine and leaves an alkene behind? Well, that's just an elimination reaction. And specifically, an elimination reaction that gets us to the less substituted. So like some leaving group there. We could pull either of those H's off, but we want to pull the one from there. So we need the Hoffman product. So basically we just need a bulky base. And that equals that. So right away, I would just treat this with some bulky base. My go-to is terbutoxide. That gets me to that alkene. And to turn it into that, I just have to hydroborate. And that was a two-step process. Remember that reaction? This is only like 2 reactions. You just gotta piece them together. Not too bad? Let's try some. So there's one. There's another. It's really only 2 reactions you have to use for each of these. It might be more than 2 steps, but only 2 reactions. Just think backwards. Think what those products could have come from right before that.
That's the only thing we know that's gonna get that, I think.
Yeah, it is.
Cause we would have another product, but we're only seeing one
Yeah,
product.
yeah, yeah, okay.
No, you're right. That's top right.
Wait, are you sure that that comes from that website? Is it this or that?
This side.
But why would it just be
No.
where's the left?
Oh, wait. No, it would be
The double bond
in the middle. Yeah. Yeah, yeah. This would be.
There is something that turns you on, is it? Isn't it?
Yeah. Yeah.
I think there's an E2 reaction for that, and then there's also an E2 reaction.
Yeah, wait, what's that? You could probably do an E2 here. Yeah. E2 with.
I think it's in E2 with the base and then wait, actually you get the double one turn into.
So we can, no, we can do. Actually, this would be 3 steps. So I'm thinking we could H2 PVC this and get rid of the double bond. And then we can, do we know a reaction to just add a bromine? Or can we add a bromine? Oh wait, no, should we add a bromine?
Add H2.
Yeah. Oh, yeah. Oh, yeah. No, I think you can just do HBr
Oh, no.
Yeah, you can do it, yeah.
onto the double bond and then that gives you a bromine on the more substitute side.
It needs to be in, on the first one?
Yeah.
Isn't it just that used to be?
Yeah.
It should be, right?
Yeah, I think so.
Yeah, it needs to be strong. You want
E2 with.
E2 with. Yeah.
That's strong. Same with this
Oh, okay. That wasn't actually that bad. I just need to lock in. On Friday I have this exam. I have a Spanish presentation that I barely even worked on, and I have a simulation for Go. And I didn't like no work yesterday because I didn't feel good. bulky base goes to less substitutes.
You're right.
Is any LS any LH or
Any OH. So you just do OH, but that's a strong. Do you want? Well, it depends. We want a small base, but we also want it to be. Wait, we probably want a strong base weak nucleophile. Right.
My teacher?
Sure. So which ones are strong bases weak nucleophiles?
wait, no. Wait, no. Strong base weak nucleophile.
Oh, are the big ones? Are the big ones? Yeah. So I guess we just gonna need to. Yeah, just because that's just the function work. So we'd probably get the E2 product as well. Or the SN2. Yeah, we'll do.
Yeah, so
That's a sure.
Oh, it's a wavy one.
Alright, so this should be. This one. Or Roy. Yeah, right, shouldn't this be like said too?
This one is going to.
Oh, no. Not like that. Oh, I was thinking this was yeah, that's why I put it within a slash. It's a different step, yeah. It just looks like a song. Yeah, it's gotta be a word. Oh, dang. I think Ben says I think it's gonna lose aura.
Oh, yeah.
I scheduled this like last week.
That's what I'm normally like.
Yeah, because OH show. No, it's good. So, the H2O is not. That's right. So thinking backwards from here, I only know a few ways to make alkenes, and usually it's through some sort of elimination. If I'm designing a synthesis, I'm probably going to prefer to do an E2 over an E1. It's just better. And that could have come from something like that, or even something like that. If I'm thinking about how I could have made this from this, well, that's just our old friend, HBR edition. And I think this would actually rearrange and make this, but both of these can E2 to this same alkene. So I do want this is the Zaitsev product, so I do want to use a small strong base, so ethoxide will work for that. It's pretty small. I don't know if I've used that word much, but that's ethoxide. ET for ethyl. Here we've got an aldehyde. We've got two options for making aldehydes that we've learned about. One is we could have an alkyne, terminal alkyne, and what was this? This was, again, a hydroboration. It makes that enol, you tautomerize to an aldehyde. So that would work from this alkene, but it's not immediately clear to me how we could make this or this alkyne from this alkyl halide. So the other option for aldehydes is ozonolysis. Remember that kind of splits an alkene. So if you think about having two of those, that would kind of be like, I guess I should erase that. So this could have been two of these, and if I arrange them just like that, you might buy that alkene could ozonolyze to those two identical aldehydes. Making that alkene from that alkyl halide, that seems pretty doable. Again, with a Zaitsev E2. So here's my favorite small base. And ozone. And we do need the DMS, the reductive workup to get aldehyde. If we use peroxide there, we'll get the carboxylic acid. And we do want to make sure these two are separately numbered steps. What do we think? Not too crazy, doable. So you'll see in the practice exam, there's a question like this where it's just starting material and product, and then there's a question that's kind of a fill-in-the-blank multi-step scheme. Let's do some substitution elimination. So here's just a long list of reactions. I want you to tell me which mechanism is happening and what the product is.
Controlling the major products.
Yeah, just the major. Oh, and you know what? We can have more space than this. for an extra challenge, try to do this without looking at your table.
Well, I'm not done.
No. It's more than one. So, what's 3? You approve. Okay. I think it's, I mean, I feel like. I think this is just bad. I don't really, I think it's maybe. And then if it's
It's not just about eating all that stuff.
No. I don't know, I haven't looked at this yet.
make sure you finish what you have to include this part of it too. For like, it's not OH, it's O, it's your stuff with it.
Hopkins the less.
Zaitsev is more substituted, Hoffman is less. It's strong. So is it, it's also strong base and strong amplified, which is going to be, it's a
That's, well, I don't know. I think it's, it has a name to it. But I think it's strong amplified.
Oh,
That's
yeah.
that's my guess. I don't know.
Yeah, we're actually,
Yeah, I was I feel like it just has to be.
It's definitely strong, it's definitely strong nucleophiles.
Wait,
so it's a, it's an
I feel like it's SN2.
I think it's SM2. I think no matter, because no matter what, it's gonna, I think it's a strong nucleophile, I think it's SM2. But how do you even know? You throw that on there.
yeah. Oh, yeah.
I think,
Oh, but that's what's happening.
I think the lone pair just attached.
yeah, I think it's like this. Yeah.
I'm pretty sure there's both of them.
So it looks easy.
I think that one is also the same thing.
Yeah, I think there's like
Well,
one
this could be
more,
SN1.
this is also.
But you because you got a weak base, tertiary. So that'd be SN1, I mean, sorry, second, yeah, it's not tertiary, it's, so is it the, it's just a small one, special. But I don't know if you can do one. I think that's.
You're always gonna get things like that more so. So the, you could be one.
We understand it's more than that.
Well, like it doesn't matter which. Like what? Like it's always gonna be. No, but with E1 it's always at 7.
I really went through all the more like some like information that was there, like just on board guys with the chat and stuff.
Okay. So then, that's a small thing. Yeah. That's it.
Well, then they only have.
What's the difference between E1 and E2 products?
Yeah. And those are only like that aren't ion.
E2 could do ion.
Well, yeah, because you can use both
I don't know.
Well, maybe you can't have like
So I want to approach all of these by considering my reagent and my substrate. NaOH is just hydroxide. Strong base. Strong nucleophile. Small. This is the primary substrate. It's going to be SN2. All right, nice and unhindered, easy to come in with the nucleophile, displace that leaving group. It does do the inversion of the tetrahedral center, but not chiral, can't really tell. Terbutoxide. Remember that's an O- there, that K is just a counter ion. Strong base, weak nucleophile. Primary. It would be a good nucleophile if it wasn't so bulky, but it's bulky. But it is strong, so we can still do E2. Really only one alkene we can make there. Here we got a secondary substrate. I don't think I've drawn this for you before, but this is isopropanol. It's just an alcohol. It's ROH. That's weak base, weak nucleophile. It's just like water or methanol or ethanol. So weak base and weak nucleophile, but as long as it's secondary or tertiary, we can still do SN1 and E1, and it will probably be a mix. Actually, let me match. But it brings along its R group when it attaches. And then for the elimination, we're going to prefer the Zaitsev. They're the most stable one, really. So Zaitsev and trans. Here we got our primary substrate again. This looks a little funky, but you've seen it before. Negative charge on carbon. That's going to be a strong base. This also happens to be a strong nucleophile. Strong nucleophile with a primary substrate, nice and unhindered. That's just an SN2. Let me number carbons here. Cool. Yeah.
What is the name of that thing?
This, it's some sort of acetylide ion.
If you were like writing it out in like letters, would it like C? Is it just C3?
if you want to write it out linearly, I mean, you might write
It is, it's.
just like that.
So it doesn't have like a name,
I'm sure it does.
but like a generic
As
common thing.
as generic common, I'd say acetylide ion because it's based off the acetylene. And we've seen this before, right? We talked about this back when I introduced alkynes. And remember back then I told you it had to be a primary substrate? Well, now you know why, because if it was secondary, it would do an E2 instead. It all comes back, guys. Yeah. Okay. Water. Weak base, weak nucleophile. But it's tertiary substrate. So we can still do SN1 or E1. I'll just put an HO there. And give us the Zaitsev alkene. Secondary substrate. Small. Strong base, strong nucleophile. So strong base, strong nucleophile, but it's secondary, so we're gonna prefer elimination. E2, and it's small, so we'll prefer the Zaitsev alkene. How are those? Not bad. Okay, let's see. I've got a bunch of stuff that we're probably not going to get to everything. So, would we rather see a couple more problems like that or some more schemes?
Schemes probably.
Scheming. Let's go. Actually, let me just skip down here then.
What do you rock over break?
That wasn't me. I didn't want to. My team's on here too.
Use reagents.
I know that's saying like, you know, like, when you have the alkane we can add stuff to it. So one side. Yeah.
So you can use whatever reagents you want, just as long as nothing you're adding has more than 4 carbon.
It's not like.
This is not my first paper, this is before I ran out.
There's like, this is one that's much, right?
That's what I'm saying. No, like.
I think I got the first one.
Oh.
Yeah, that's big. It's too.
Yep, yes.
Some of the regions can be little things, but you can only get to it.
But it's gonna be, but it's all right?
We said we could use all the reactions, so. Well, it feels long.
That's from.
Why is it VR squared? It's 30 VR. I don't know, but you're going to
Be like a.
Yeah, it's this one.
That has a side.
I got this.
Yeah, maybe some type of place.
Wait, are you?
Is it substitution or is it?
Oh, I think, wait, I got it.
I thought you were still gonna do.
I'm thinking, what if we, first I'm thinking, we could do an MCPBA here, then we get a double bond, then we can deals all there.
How do you make it like this?
Break it up.
Don't we need these?
And then, I don't know.
Not both of these.
That was just an idea.
So,
Yeah, right there. Maybe. Cause then.
Because
you
like, I gotta finish this one.
Yeah, that would.
a strong base.
Oh, shit.
I said what? A strong base on what?
It makes the, you know, it's not that.
We do your own.
That would be like here, right, that would be the hot ones on it. So.
That's true.
So we would.
But it has, if we, no, I wanna think of that, I can think of it. I wanna take this, I wanna take the
So that would be the
cyanides,
first step,
cause I
right?
think the cyanides might be able to hit, cause can't you replace, if you don't want like replace milk or something. No, but like there's like a way, is cyanide,
Can they SM SM2? Like cyanide is a thing that can do SM2 and replace it.
yeah. I think, wait, I gotta do this step by step. I'm feeling like
And then there's always.
good about the MCPBA. Crap, what's those under the MCPBA, because the two-step ones?
He's gonna get.
I know. Yeah, okay, that's it, it's really approximate. Or, Pedro.
I was going to.
Alright, so this.
You keep doing this, you keep getting me to. I wanted to take that.
I'm sorry.
Once I asked, was like, wait.
Yeah.
It works for me, so it's, no, it didn't work for me because I have
How do we turn this off to?
Yeah. And it's like not the first time we do, but it's still, I remember you. No, I even like
That's
them
cool.
on the.
I guess it's. Oh,
I like how you. I was true, because the loss of my eyes is the first thing, at least with Oregon.
Oh no, maybe we do want, no, maybe we do want this one. 1, 2, 3, oh wait, 2, 3, 4, 1, 2, 3, 4. There you go. This only has 2 parts, wait, no, we want this one. Wait, do we do, it's double E2?
we saw that there's
Double SM2, double bond.
Yeah.
But what guess if you V2 this, it will go there, and if you V2 this, it will go there.
Yeah.
But that was because.
But then there'll be trans, but then we can fix that. I don't know.
He's so good.
It's not how big
We can fix
No,
that.
because if you have this, can you not turn that? Make it cis. It's just less stable, but I think you can turn that. Because it's not, because it's.
Maybe we don't even have to do MCPBA. Because if we just start with this being trans, because these two things are trans, we could just start with the deals holder. Yeah.
Start with the deals holder.
Start with
That's
the
what I
deals
thought
holder.
too.
Trans. Because the OH is here. And here.
Wait, you're on something.
Oh my God.
Grab something. Wait, okay, wait, let me.
No, it was Donald.
It was not racist.
Ronald McDonald? Scary exams.
This would be good.
Scary exams.
Wait, are you sure?
They're
No,
fun.
Good.
Scary exams. Scary exams.
You can get all that scared.
Good. Yeah, very scared.
Mm-hmm.
But I feel like
My brother said it surprised me that you listen to it.
I'm still messing with it.
We were
Yeah,
contemplating.
that's turkey boxing. That's whatever.
Is that not?
Probably want to die.
Well, the thing, but you can't do this all the first because you need a double bond there.
But it's gotta be like
What if we do? So you
Because
can.
we still do, I think we still gotta do MCPBA first.
Two nitro. Wait a second, I think we'll start. Like, how you get ready, so it's all there besides that.
Well,
Turn into it.
Yeah, well, it wouldn't be like, how do you get? Yeah, like this. What do you say?
no, this side. That's the other one.
Are you able to like flip this so it's trans?
I'm sorry.
Okay.
That's the one.
Okay, that's what I thought.
Realistically, the whole
It's gonna be trans. Okay, okay.
Probably in that country.
Okay. Okay. So yeah, so then we can do,
You have to do two E2 reactions.
that's what I'm saying. I think so, a double E2.
a bunch of strong base
Right, so I
Two,
take
we're
that
gonna
down.
be, but we're gonna be,
It was an 8.
wait, it's gonna be, we want,
Tapped out.
Wait, no,
I
no.
want to- Wait, I'm so mad. I realized I have to cancel
I don't think it's gonna go,
because someone booked themselves in the country.
it only has one direction.
And I realized, I thought it was like, until last night, I was like, oh, I
Because
didn't.
these are primary, so it's not saying they can do each two.
And then
Hey, I'm not the only one.
Yeah,
Yeah, same. Just go, I get cloud for it. I'm not trying to pay for that.
So like,
My top albums are
and then
very
like 45.
and my top songs are
Let's put the sheet okay and then multiple.
I don't know if I should go first, it's just not the
No, you just throw a bunch of solution.
I didn't try to do that. But someone
Oh, I just realized I forgot to draw
booked
the steps. Oops, I drew this as,
instead of like,
One of our teammates is a big Madonna guy.
Two is a triangle.
celebration.
I don't know,
two is a triangle.
prayer.
Yeah, that's in the album.
Yeah.
I think he doesn't like
No, he can't do it.
well, it's 10
Oh.
Imagine not being a sensitive.
How was yours?
I was twitching a lot yesterday because right eye kept
Claire.
Oh my gosh, Clara was calling. I wish we could quit. I think we could do it and we should only listen.
Okay.
Sophia.
Two bromines added anti to each other. We know that one. Old favorite. That probably came from this alkene. I can certainly get that alkene from this alkyl halide with an elimination. I just gotta remember it's gotta be Zaitsev. So use a small base, small strong base. Ethoxide will work. MBR2. Great. Two bromines. That's probably BR2. We can't really tell it's anti because this isn't a chiral center, but these certainly could have been anti-addition. And that's coming from this terminal alkene. I can get that alkene through an E2. I just need to make sure to use a base that gives me the Hoffman product. So I've been writing K a lot, but that's really just terbutoxide like that. So I just need to use a bulky base to get me the less substituted alkene. And BR2 again. Those okay? Make sense? Okay, now the fun one. How many reactions do you know that make a 6-membered ring? Yeah, pretty much just that one, right? But Diels-Alder products have a pi bond in them. This doesn't have a pi bond in it, so it's probably Diels-Alder, but probably not the last step. So I'm looking for some sort of alkene reaction that could have made this. I see 2 hydroxides, added anti. Well, I know an alkene reaction that does that. That's 1 and 2. That's just our trans diol. So that could have come from this. That looks like a Diels-Alder product. So if I just split that apart into what the 2 Diels-Alder components would look like, it'd be that. This is a 4-carbon thing that I'm just invoking as a reagent. How did I get this diene? You can also think of that as that, right? Oops. Just a conformation change. In solution, it probably exists like this most of the time because that's the more stable conformation, but it just rotates into this to do the Diels-Alder. But that's what it looks like, and perhaps it's easier to see than that that's just an E2, but twice. Ethoxide, just an excess. Realistically, if you're running an elimination, you're using excess base anyway. too. I'm not going to try to draw it there, but that 4-carbon dienophile. Then MCPBA and the acid workup to open it up.
Wouldn't a small base do SN2 for a primary?
Oh, you're totally right. Let's use terbutoxide instead. Nice. Yeah, that feels pretty good to me.
Can we just draw the triangle
Triangle.
The
for the second
delta
step?
for heat.
Like instead of writing the word Titan 5.
Well, you gotta at least draw this somewhere then.
Okay, yeah.
Yeah. And fun fact, if you don't do this acid workup, you just do MCPBA, you end up with so that's just epoxidation like we've been talking about in lab.
Wait, do we need to write that?
No, this is just for fun.
What in the? What is that?
And epoxide? Like in lab. You say that. Yes, that's what I said. I said you get making epoxide. I did my research.
You get the enantiomer too. So yeah, sometimes you do want to make epoxides because they're useful for stuff. But that's it. Good luck on the exam.
Thank you.